Hello everyone. In the previous class, we mainly learned about the classification of ground improvement methods. Today, we will study section 2 of chapter 3, which focuses on common ground improvement methods. In engineering projects, commonly used ground improvement methods include soil replacement with cushion layers, preloading with drainage consolidation, composite foundation, and so on. The following is a detailed description of these commonly used ground improvement methods. First, soil replacement with cushion layers. When the bearing capacity and deformation of soft soil foundations fail to meet the requirements of buildings, and the soft soil layer is not very thick, part or all of the soft soil within the treatment depth below the foundation base is excavated. Subsequently, it is replaced in layers with high-strength materials such as sand, crushed stone, granulated blast furnace slag, fly ash, or other stable, non-corrosive materials. These materials are then compacted to the required density. This ground improvement method is known as the soil replacement with cushion layers method. The construction process for the soil replacement with cushion layers includes surveying and setting out, excavation of the soft soil, inspection and approval, backfilling the cushion materials in layers, compacting each layer to the required density, and final inspection and acceptance. Second, preloading with drainage consolidation method. The drainage consolidation method involves preloading the natural ground, or first installing vertical drains, such as sand drains, bagged sand drains, or prefabricated vertical drains in the natural ground. Subsequently, the load is gradually applied in stages using the weight of the structure itself, or by preloading the site with surcharge before the construction begins. This process allows pore water to be discharged, leading to gradual soil consolidation, ground settlement, and a stepwise increase in soil strength. The drainage consolidation method is commonly used to address settlement and stability issues in soft clay foundations. It allows most, or nearly all, settlement to occur during the preloading period, preventing excessive settlement and excessive differential settlement during the building's service life. Additionally, it enhances the shear strength of the foundation soil and improves the bearing capacity and stability of the foundation. The drainage consolidation method consists of two main components, a drainage system and a pressurization system. Next, we will introduce two commonly used preloading methods in construction: surcharge preloading and vacuum preloading. First, surcharge preloading method. This method involves applying equivalent loads either in a single stage or incrementally to the proposed construction site using earth fills or other surcharge loads before building construction. The preloading process subjects the foundation soil to pressure, facilitating the drainage of pore water, reducing pore volume, and compacting the foundation soil. As a result, the shear strength of the soil increases, enhancing the bearing capacity and stability of the foundation. Additionally, it reduces the compressibility of the soil and eliminates settlement, preventing detrimental settlement and differential settlement during the service life. The treatment depth achievable with the surcharge preloading method is generally around 10 meters. Second, vacuum preloading method. The vacuum preloading method first involves laying a sand cushion on the surface of the soft soil foundation, requiring reinforcement. Vertical drainage channels are then installed, and an airtight sealing membrane is used to isolate the ground surface from the atmosphere, with the edges of the membrane buried in the soil. Through the suction pipes embedded within the sand cushion, a vacuum device evacuates air, creating negative pressure in both the surface sand cushion layer and vertical drainage channels. This creates a pressure differential between the interior of the soil mass and the drainage system, which consists of the vertical drains and the sand cushion layer. This pressure differential causes pore water within the soil mass continuously drains out through the drainage channels, thereby promoting soil consolidation. Third, composite foundation. A composite foundation refers to an artificial foundation formed by either partially replacing the natural soil or installing reinforcement materials into the natural foundation during ground improvement. The reinforced zone consists of two parts: the original soil matrix and the reinforcement body. Pile composite foundations are currently the most widely used type of composite foundation. Today, we have reviewed common ground improvement methods, focusing on three key approaches: the soil replacement with cushion layers, the preloading with drainage consolidation, and composite foundation methods. A rational selection of ground improvement methods can effectively prevent foundation-related failures. cultivates students' safety awareness and awareness of protection measures, and enhance their professional competence.